Good afternoon everyone, my name is Sriraj Gupta and our project reference number according to 45th series student project program organized by Karnataka State Council for Science and Technology is 45ES_BE_3025 and our project title being Low Cost Solar Power Refrigeration for Village Pushcart Vendors. I'm making this video as part of midterm evaluation of my project. In this video, I'll be discussing the methodology, circuit diagram, and in the end, I will show the working demonstration of our project. This is a Peltier module which works on 12 volts DC supply. This being a heart of our project is used for cooling purpose. What you are seeing is a cold side of the Peltier module and the back side of it is a hot side. When connected to supply, we can see instant cooling effect on this side. The temperature difference between cold side and hot side will be approximately 30 degrees Celsius. That means to say that if we are able to maintain 30 degrees Celsius on the hot side of the Peltier, we can reach up to 0 degrees Celsius on the cold side and use for refrigeration purpose. This is a digital temperature control unit with high precision NTC sensor. Is connected in series with supply and load, and this is used to maintain the temperature inside refrigerator at desired levels. It has got some presets to set the reference temperature, below which it cuts off the supply to the load, and the presets include time delay and hysteresis. This helps in saving the power. The NTC sensor is freely suspended inside the refrigerator unit. This is a DC to DC buck converter used to get constant supply from the source. In our project, we are using this buck converter to get a constant output from the battery to power up the Peltier module. This is a heat sink and this is a cold sink made of aluminium metal for temperature conduction from Peltier. A Peltier module is sandwiched between the heat sink and the cold sink. The whole assembly is then placed in such a way that the cold sink goes inside the refrigerator unit and the heat sink is exposed to atmosphere for heat conduction. We have used thermal paste while sandwiching the Peltier module between cold sink and heat sink for better heat transfer from the module. These are the DC fans we are using in our project. The bigger DC fan will be attached to the heat sink as I am showing now, which is used to extract all the heat from the heat sink and let it to the atmosphere. The smaller DC fan will be placed on the cold sink and which is used to blow the cold air inside the refrigerator and helps in uniform cooling of fruits and vegetables. This is a 12 volts solar panel of 30 watts used to charge a solar rechargeable battery which is used to power up our circuit. This is a circuit diagram of our project. What you can see is the cold side of the Peltier module shown in the circuit diagram. The positive of the Peltier module is connected to digital temperature sensor and the other terminal is connected directly to the battery. We also have a NTC sensor freely suspended into the refrigerator unit. The digital temperature sensor requires a separate supply which is given with the help of 12 volts battery. We also have a 12 volt DC fan. We are using two numbers of DC fan, one inside the refrigerator unit and the other one on the heat sinks for the purpose of cooling. What you are seeing now is the heat sink attached to external box of the refrigerator unit. This is an exhaust fan attached to the heat sink to extract all the heat from the heat sink. What you are seeing now is the inside of the refrigerator unit. The metal part here is the cold sink. A fan is attached to the cold sink for uniform blowing of cold air for refrigeration purpose. An NTC sensor is connected directly to the cold sink for measuring the temperature. Since time is the constraint, we have directly connected the temperature sensor to the cold sink to show the potential of our project to cool to lower temperature for refrigeration purpose. In digital temperature unit, we have set the reference temperature to 1 degree Celsius, below which sensed by the temperature unit will cut off the supply to the Peltier. In the other preset, we have set it for cold applications. The amount of change before the relay enables the supply for the unit is set to 4 degrees Celsius. And doing this will help us saving the power. Now I will switch on the supply. Once I switch on the supply, the cooling happens instantly and the sensor displays the real-time temperature of the cold sink. Here, the temperature of the cold sink is around 19 degrees Celsius. The temperature is dropping rapidly because we have connected the temperature control sensor directly into the cold sink. However, in the real time, the refrigeration happens at a same rate of conventional refrigerator. And the temperature dropping takes some time. Since we have time constraint, I will be pausing the video and I will resume the video once the temperature inside the refrigerator unit reaches the desired levels. Now that our project has been running from quite long time, we are able to see a temperature of 1.2 degrees Celsius inside the refrigerator unit. We are still waiting for the temperature to reach negative to show the potential of our project to refrigerate fruits and vegetables at negative degree Celsius. I am doing this to show the potential of our project, which has got the same potential as conventional refrigerator units, but still being compact can be adopted in pushcart vendors. The temperature now has reached 0 degrees Celsius and we are waiting for it to reach minus 0.5 degrees Celsius. I will be pausing the video right now and I will again resume once the desired temperature is achieved. After running for 2 more minutes, we are able to see minus 0.5 degrees Celsius inside the refrigerator unit. And we can still see the temperature reducing. Now the temperature is minus 0.8. The relay will cut off the supply and again gives the supply once the temperature rises 4 degrees Celsius. I will resume the video once we are near the desired temperature. After some time, we can see the rapid increase in temperature. Once it reaches around 3.7 degree, which is 4 degree rise in temperature, the relay unit again gives the supply. And once the supply is given, we can see the rapid decrease in temperature. This does not happen in real time. Just for the demonstration purpose, as I have connected the sensor to the cold sink directly, we are able to see. However, in practical application, we can see the rate of refrigeration will be as similar to conventional refrigerator units. Now I will be showing you the inside of the refrigeration unit. Inside the refrigerator unit, we are able to see the formation of ice, and the ice have melted and we can see the water. I will also be focusing on the cold sink now to show the formation of ice on the cold sink. Now what you are seeing is inside of the refrigerator unit. After running it for a quite long time, you can see the formation of ice on the plates of cold side. Once I touch this, you can feel the formation of ice, and once I touch it, it melts and becomes water. This is how we can use our refrigerator unit for the application of storing fruits and vegetables in pushcart. After running for quite long time, we are able to see a temperature of minus 3.5 degrees Celsius inside the refrigerator unit. I will be showing you the inside of refrigerator unit now. I will take you inside the refrigerator unit. You can see the literal formation of ice inside the refrigerator unit. Let me focus. This is the formation of ice. And also you can see a bits of ice inside the unit. The main objective of our project is to store unsold fruits and vegetables at the end of the day at refrigeration temperature. By doing this, we can resell the fruits and vegetables the next day, and this will promote non-pollution, and this will reduce pollution directly and indirectly and saves our environment. Thank you.